Welcome, beginning IB physics students. We're going to do some data work on Excel, and Excel is a pretty good spreadsheet if you're just trying to deal with numbers and you're not trying to make graphs. So in our lab that we did in class, we were measuring blocks of cheese, and you were cutting your block of cheese down like this. Oh, I'm wearing an umbrella because it won't stop raining. And the block of cheese had a set height and a set width, and we reduced the depth, and so we got reducing masses as the block of cheese got smaller. Now you want to make a graph of volume on the x-axis and mass on your vertical axis, so then the slope will be density. So you need to put in a formula for volume. So you're going to put in equals the height, which in this case is 5.6, times the width. Now you'll have your own values here, so don't put it in mine, times, and you'll reference this cell here. Boom. Then you should be able to fill down, and boom, it gives you smaller and smaller volumes. So we can get the graph easily from this. Let's talk about uncertainties, which are going to lead to error bars. The mass is going to have probably a very small uncertainty if you're using an electronic balance. For example, I chose 0.04 grams, and that's a very minuscule percentage of once you get up to around 100 grams. But the volume is going to have a very significant error that's going to change. So what I need to do here is talk about how I got these values. I just chose randomly 0.3 centimeters for the height. Now I'm going to put in 0.3 divided by the 5.6 and get a percent error of, I think, about 5%. Then over here, for 0.1 centimeter, I have 2.5. That percent error is going to be something like 4% error, something close to that. Then for all of my depths, I chose an uncertainty of maybe 0.3. Don't use these same values as me, but this is going to change. So I'm going to put in a function of 0.3 divided by this cell here times 100. So that's going to give me a 4.5% error at first and an increasingly larger percent error as you get smaller. And so this is going to be the percent error of depth. Now this is needed because for the overall volume, we want to have the total percent error. And because volume is calculated by multiplying depth times height times width, when you have a multiplication of values that all have a percent error, you add all the percent errors. So I'm going to make a formula here that is going to say always do 5% plus 4% plus whatever crazy percent is here. And once you might have some, you need to tell it to format, tell how many decimal places you want. 1 decimal place is okay for me. Then fill that down, and you should have percent errors that, in this case, continue to get larger. Maybe that's too many. Maybe I don't even need a decimal place. Maybe I can go to 0 decimal places. It might make my life a bit easier. Later on in your graph, when you're trying to insert your error bars, you might find that instead of dealing with a percent error, an absolute error is a little bit easier for your graphing program to deal with. So let's insert a column here, and let's make another column for absolute insert of volume, and since it's absolute, it's going to be in cubic centimeters. Now I'm going to put a formula in here to take this percent error and turn it into a fractional error by dividing it by 100. And I'm going to multiply the percent error by the total volume of that particular data point. And then if I fill down, these tend to get smaller. So if you look down here, I'm taking 42% of only 12.6 cubic centimeters, so that's why I get a smaller absolute uncertainty of about 5 centimeters. And now you're pretty much ready to graph. Keep in mind you're going to put on the x-axis your volume, then on your y-axis you're going to put your mass, and I imagine the uncertainty for mass will be inconsequential. The uncertainty for volume you do want to put in here. You can graph on whatever graphing program you want. You can graph on Excel. Graphing on Excel kind of sucks though. So we'll talk later about how we're going to graph it if you enjoy awesomeness.